Data transformations or ETL pipelines are one of the core capabilities of every data and AI platform. For big data in particular, Apache Spark is the go-to framework for distributed data processing. And the Databricks founders are actually the original creators of Apache Spark. Therefore, obviously, Databricks is a great platform to run your Spark code to transform your data across the Medallion architecture. Now, to make data processing pipelines easier, more reliable, and also more performant, Databricks a few years ago introduced an ETL framework called Delta Live Tables, which has recently been open sourced as part of the Apache Spark project, and it also got a rename to LakeFlow Declarative Pipelines or Spark Declarative Pipelines, as well as some major updates within the framework itself. In my opinion, declarative pipelines offer the following major benefits. First of all, they unify batch and stream processing as they provide this declarative interface to write your pipelines so you can easily switch batch and streaming whenever your requirements change. Additionally, you get data quality functionalities right built into the framework, and declarative pipelines are really built for incremental processing, so it becomes super easy to write those pipelines where you always only propagate your incremental new data changes throughout your whole pipeline. And you can also do things like change data capture and slowly changing dimensions with just a few lines of code. After you've implemented your data processing pipeline, you probably want to orchestrate everything. And for this, Databricks offers LakeFlow Jobs, which was previously known as workflows, to orchestrate your whole pipeline, to put a schedule on top of it, to define triggers, job parameters, and much more. In this video, we will use LakeFlow Declarative Pipelines to build our silver and gold tables by implementing pipelines to clean the data, to apply some data quality checks, and then to join it to make it ready for consumption by downstream applications. This is the fourth part of an end-to-end Databricks project. So check out the first three parts if you're interested, where we ingested data from a SQL server, also streaming data from a message bus, as well as from the object store. Now, let's jump right into Databricks and get started. All right, let's go. Here we are within Databricks. And as always, let's quickly check our catalog structure. We are still operating in the Smart Claims Dev catalog if you have watched the previous videos. And today we will be mainly focusing on the silver and the gold schema as we are building the cleaning transformations as well as the aggregations. So let's quickly check maybe again what we have already here. Within the landing schema, we have all the volumes, right? So here we have the volumes that were created by our ingestion gateway to ingest the SQL Server data, as well as the volumes that we created to upload the images. And then in Browse, we created all those different tables for the claims, for the claim images, for the customers, policy, telematics, and all of that was ingested in the previous parts. And now we would like to transform this data. We would like to clean it, and we want to put it into a structure so that we can consume it by downstream applications. And for this, we will clean the tables and put it into the silver one, which is currently empty. And then we will also have this gold schema where we will put the aggregated data into. Now for this, we would need to write some code. And for that, we will again create some LakeFlow Declarative Pipelines. So we click on New ETL Pipeline right here. This time we call it Transformations. And then we select our catalog, and the default schema this time should be maybe the silver one. And we will again use the new LakeFlow Pipelines editor. And for now, let's start with an empty file. Now let's give this some structures. Let's create some separate files for the different stages. We will create two new files for Browse to Silver and for Silver to Gold. Now let's start with the actual implementation of the Browse to Silver pipelines. For this, first of all, we will import some functions as well as defining our catalog, Browse schema, and Silver schema, as we will refer to this several times within this file. By the way, this could be also later on abstracted away into pipeline configurations. But for now, let's just hardcode it right into here. And now we can start cleaning our data, and let's start maybe with the claims data set. To do that, let's maybe quickly first open a new tab to have a quick look into the data set, right? So we query from the Browse claim table, and then we see how it currently looks like. It is already in a quite clean state. But what we see here, for example, we have lots of dates inside here, like the license issue date, and they are actually in string format. So we would like to convert them into date format. And this is one of the typical cleaning operations that you do from bronze to silver. And then we would also like to do some data quality checks to make sure that very important columns, such as the claim number, for example, they are not zero, right? They have a specific value. And then we could also apply some other checks on the other columns using the built-in data quality functionalities within the declarative pipelines. So let's do that. So we paste here our initial code. This is just defining, again, the name of the table. In this case, we will put it into the silver schema. We will call it exactly the same as we call it in the bronze schema. So again, it's just called claim, but this time in the silver schema. We will set some table properties to enhance the metadata right here. And now we will add our data quality checks. And for this, we can leverage this built-in data quality functionalities within the declarative pipelines. So what we do here, for now, we could add much more here, but we will just focus on 2 quality checks for now per table. And for this claim table, we check 2 things, right? First of all, this is the syntax, how you create those data quality checks within the declarative pipelines. So you just specify right before the table definition, you specify expect all, for example, if you have multiple checks. And in this case, I am defining 2 data quality checks. And then here I specify the actual logic that is used to perform this data quality check. So here it's super simple. I'm just saying claim number is not null. And then I have a second check, checking for the valid incident hour, right? We have this column called incident hour, and I just want to make sure it's between 0 and 23 to make sure this is not some weird number that does not make sense. So now you might be wondering, okay, what if one of those data quality checks right here is not passing, right? So what if I have a claim number that is indeed a null? Or what if I have an incident hour that is maybe 45, right? The default behavior, as I just specified here, expect all, is to give me a warning, right? I will see later on in the user interface, there were several records, maybe out of the 1,000 records that I ingested, maybe 10 of those did not pass this data quality check. And then I will see it visually as a warning, right? But maybe that's not enough. Maybe I want to have different actions based on the results of these data quality checks. So what I could do here as well is, instead of saying expect all, which just would give me the warning, I could also say expect all or drop. So actually, for those records that do not pass these data quality checks now, it would drop the record out of the target table. And this is most likely what we would like to achieve for most of the use cases. There is one more alternative that we could do. So instead of saying expect all or drop, we could also say expect all or fail. So now if one of the records of my source table does not pass one of those 2 data quality checks, then it would fail the whole pipeline. If I would want to make sure, okay, if any of my input records, something is not passing those 2 checks, then maybe I don't want to continue at all. I first want to fix on my source system what the problem may be. Then you could also specify this behavior right here. For our use case, we go by expect or drop for now. And now we can go ahead and specify what we would like to check. So first of all, we are reading in our browse table right here, right? Performing a read stream operation. And then we are returning this browse table with a couple of modifications on top. And these are our data quality checks that we perform right here. So if we make this a bit bigger, you can see for this table, our main transformations are adjusting the date format. And this is also very typical. So in a lot of the cleaning pipelines, you often mainly do some data quality checks, plus you do some data type transformations to put everything into proper data formats that you expect down the road. So here we are making those transformations on 3 different columns: on the claim date, on the incident date, as well as on the license issue date. And as all of them have a slightly different date format, you see here that I specify, okay, in this case for the incident date, it looks like this currently. And for the license issue date, it's like the other format that you can see right here. The rescue date is something we got out of our first ingestion pipeline. If you have followed the last video, when we used autoloader, and here we are dropping this for our silver table. Now, before we add all the other data quality checks for the other pipelines, let us quickly run this and see what the outcome looks like, especially with our data quality checks that we apply now. There we go, the pipeline is being executed, and we should see the results in a second. There we go. So now we have created our silver table. We can have a look into it and look at the preview tab of this LakeFlow Declarative Pipelines. And now you see already here the icon, and also if we hover over it, you see the claim date is now a proper date format. And what we could also do is we could go back right here in this overview, and then we could have also a look here into the expectations column. If we click into this, we see an overview of our data quality checks that we performed. So we see in this case, 100% of the source records were written into the target table. So all of those quality checks passed basically. None of my rows did have an invalid claim number or an incident hour. So nothing was dropped. But if I would have some records right here, I would see them right in this overview and they would not appear in my cleaned silver table right here. All right. Now let's repeat what we have done for this claim table, also for all of our other tables. I will not go into the detail for all of those. I will just show you some other common data cleanup steps for the other tables as well. So now let's maybe continue with the policy table, as this is also very straightforward. Here I will just copy over all the code. So again, it's super straightforward. All we do here is we are checking for a valid policy number. And here we don't have a date that we would like to clean up. But here what we do is with this premium column that we have right here. So this one does have like values that could be negative. But in the clean version, I would always like to have only the positive values. So I'm applying this absolute function right here to, from the negative records, also store the positive records in this table. Now, maybe let's also have a look into our customer cleanup operations. Here, we are doing a few more things. So if I just paste this right here, again, going quickly from the top to the bottom, I perform a check on the customer ID. Then I read the bronze table right here. Actually, for the customer, I have this name column, which is having the first name as well as the last name, which I would like to split here. So I'm performing some transformation logic right here to basically get the first name and the last name out of this one big string. So if we check it out very quickly and query the bronze customer table, this is what I was referring to, right? Currently in the bronze version, we have only this name column where we put the first name and the last name. So here maybe we would like to split this, and this is exactly what we are doing in our cleaning pipeline. On top of this, for the date of birth column, in the customer table, we again transform the data type to get a proper date right here. And then I'm also doing some cleanup on the actual address column right here. All right, now I will also paste all the other transformations that we do, all the other cleanup operations. I will put all of the code into a Git repository after this whole series so that you can have a detailed look in each and every of those table transformations. But yeah, for all of them, it's really very similar. We're doing this data quality check. We are adjusting the actual data types of the columns. And then maybe for some specific tables, we also apply some logic to do further cleanups. So let's not forget about our image tables. So here we're also doing some cleanup operations on the claim images as well as on the training images. Now we have put this all together and we can again maybe run the pipeline. And now you also see the graph will become a bit bigger as we have now lots of tables that we create right here. And there we go. So we were super fast. We created all of these tables right here, all of our silver tables. Now, if we would move basically our ingestion pipelines that we have built in the last parts, in the last videos, we could also see the full graph right over here, right? But for now, let's continue like this, and we will anyways later in the Unity catalog lineage see the end-to-end flow of the tables coming from the source system and then being transformed into bronze, into silver, and now into gold as well. And gold is what we are going to look into next, right? So now all of these tables are mainly streaming tables that we have created. And now we would also like to create a couple of materialized views, actually, to have those pre-joined tables that we can then consume by a BI tool, for example, by Power BI, by Databricks AI BI dashboards, or even from our custom downstream applications. For this, to better structure it, let's do it in this other file right here. Again, we are importing a bunch of things and we are specifying our gold schema right here. And now we can go ahead and create our transformations. So let's start with a super simple one, which is the aggregated telematics. Here we are now reading from the silver table that we have just created in the other file. And now we are basically aggregating. We are grouping by this chassis number, and then we are aggregating on the speed. And then we're also averaging this location where the actual speed was recorded, right? And this is quite typical for streaming data. You have lots of small records, and most of the time for your actual analytical analysis, you don't need those super fine granular records, right? For telematics, it could be that every second or something, it captures 10 different records of the speed of the latitude, the longitude. So often you aggregate here, you put an average, and maybe you say, okay, in this 10-second time frame, there was this kind of speed in this kind of location. Now we would also like to pre-join some of the tables that we have to create materialized views that are basically pre-joined tables. And whenever something is changing in one of the silver tables, it will just incrementally update this materialized view, right? So here, if we create this new table, in this case, it's a customer claim and policy join. And if we update our silver customer table, for example, it will not recompute this whole target table. It will only update our materialized view based on the new customer record. We are, by the way, putting here as table properties gold for all of our gold tables. And here again, it's a super simple pipeline. So we're just reading in the cleaned policy, claim, and customer from our silver layer. And then we perform this join right here. We are first joining the claims with the policy, and then we return the full join also, including the customer information right here. Now let's create one final table right here, because you see here we have now this table having the customer claim and policy information. And then we would like to have one final table that actually also includes the telematics information. For this, we create this very long name here, customer claim policy telematics table. And again, we're reading in the table that we just created right here. So the customer claim policy table. And what we do here is we are joining it with the aggregated telematics data. All right, as I mentioned, all the code will be uploaded to GitHub so you can have a detailed look. And now let's also execute this part here so that we have the gold tables created as well. Maybe also to show you one more thing. So you see here now this pipeline failed as I don't have this GeoPy library installed on the serverless cluster. So to fix this, what I have to do basically is I have to go into my settings. I have to go into the environment right here. And then I need to add this dependency to also include this custom library into our serverless cluster. So I can just put here this version, for example, I save it and then I re-execute it, and then now it should all work. There we go. The run successfully completed now, and we see here our full graph on the right hand side. Again, this is missing the bronze tables because we did not put them in here yet. Otherwise it would show the whole end-to-end graph. But for now we already see, okay, we created those different tables, and you also see the input tables are mainly streaming tables that we have right here. So those optimized delta tables produced by LakeFlow Declarative Pipelines for very high performant input. And then we have on the next layers mainly materialized views that we use, for example, to have this joint customer claim policy telematics table. And again, this will help us to only incrementally reprocess this table whenever new records come in. Awesome. Now let's maybe also quickly check the Unity catalog. And then afterwards, we actually bring everything into a proper pipeline that we orchestrate and that we schedule from time to time. Now back in the Unity catalog, we click into our silver and gold schema right here. And now we see all of those tables were created right there. And we can go ahead. And what we can also do now, as in our LakeFlow declarative pipeline that we just implemented, we did not see the full lineage because we were building this in separate parts and in separate pipelines, basically. But now within the Unity catalog, if we click into the lineage, for example, let's take this target table right here. So now if we click into the lineage right here, we see those tables that were created. But then we also could potentially see the browse tables right here as well. And this is all created for you automatically, and you can even check this on a column level. So if you click into one of the columns within the table, you will see exactly where it came from and where it went to. Cool, now let's orchestrate this whole thing, right? So we have created all the code to ingest the data, to clean it, to build the goal tables. But for now, we just have done this once. And what we would like to achieve is we would like on a schedule, maybe each hour, for example, we would like to run this whole pipeline to pull data from the different source systems, meaning pulling data from the SQL Server that came in the last hour, reading data from the Kafka stream, reading data from the object store, and then only for those new records incrementally pre-process them, cleaning them, and creating those gold tables out of it, so that then our dashboards on top or our applications on top, they can also then access this newly updated data. For this, we click into the jobs and pipelines, and then we create here a LakeFlow job right here. So this is the native orchestration solution within Databricks. It also got an update recently, so make sure you have the new LakeFlow Jobs UI on here, which is currently in preview. And here we can now stitch basically everything together and put a schedule on top of it. First of all, let's select the first task right here. So it's structured in different kind of tasks. Here we could select the ingestion pipeline, and this would basically bring us to creating this whole LakeFlow Connect pipeline for the SQL Server again. As we have already created this, we just select ETL pipeline right here, and we select the demo ingestion pipeline. So if you have watched the first part, this is what was created by our LakeFlow Connect pipeline to ingest the data from the SQL Server. So we do this and we give it a name. You also see here you could add some notifications, for example, if things go wrong. You could specify some retries. So maybe for some of the tasks, you want to retry them several times before actually failing the whole pipeline. But for now, we'll just leave it as is and we create this first task. Now here we could also add the other ingestion tasks, such as the pipeline that we have written to read from the stream, as well as the autoloader pipelines that we have created to read the data from the file system. For now, let's leave it with this ingest SQL Server. And next, I will also show you how to add basically the next step. So here we are selecting again ETL pipeline. As for the bronze to silver to gold, we also created earlier in this part, we created this LakeFlow declarative pipeline to clean the data and to join the data. So here we call this cleaning and aggregation, and we select this data transformations pipeline. And this is pretty much how it works. We can also now specify some dependencies when to actually run this second task here. So we can say, okay, only if all the previous ones succeeded. If I would have different separate tasks right here, I could also say, if at least one succeeded, please proceed with this here. And then we can structure it like this. You see, there are also lots of other tasks that could be used. So for now, we were mainly using the declarative pipelines here as a task. But as you can see here, it could be also just simply orchestrating a notebook, a Python script, a SQL file. There is also this DBT integration that could be useful. You can put in if and else conditions within your orchestration pipeline. You could even do looping with this for each task right here. And you can also even refresh a Databricks dashboard or a Power BI semantic model right from within the pipe. After you have set all of this up here, what you would typically do is you would create a schedule right here. So you would say, for example, for this kind of pipeline, it is a scheduled pipeline that I would like to trigger every hour, for example, and then this whole pipeline would be executed and read the new data in from the source systems, incrementally process it through all your different stages, and then maybe even publish it to a Power BI semantic model, for example. Except from this scheduled trigger, there is also a file arrival trigger, and there is also currently in preview a table trigger that you could use. All right, and that's already it. This is how you would set up this whole end-to-end orchestration pipeline to ingest and process your new arriving data on a schedule. Cool, and that was already it for this part. So we have seen how we can create LakeFlow Declarative Pipelines and use its natively built-in data quality checks to first of all clean our data and also to apply some small transformations in this step from bronze to silver to fixed data types, for example. And then we have also seen how we can use those silver tables and then create gold level materialized views on top where we join the different tables together, but we still keep this incremental way of working. And then at the end, we have seen how we can see the end-to-end lineage, as well as how we can orchestrate this whole pipeline end-to-end and execute it, for example, on a schedule. That's it. Thanks for watching. In the next part, we'll build a machine learning model based on those training images to automatically classify the severity of an incident based on a customer uploaded image of the car, so that we can then automatically decide if a refund can be granted to a customer automatically or if further investigation is needed. Leave a like and a comment, and then I see you in the next part.